Okay, question 22. We have been given 6 cards and he takes 2 cards at random and they work out the product of the 2 numbers on the cards. So we need to find out the probability that the product is an odd number. So what we can do, we've got a combination of odd and even numbers. So we can try to figure out what combinations give us an odd number. So if I multiply an odd by odd, I get odd. Odd by even gives me even. Even by even also gives me even. So we just need to find the number of combinations of which we have an odd multiplied by odd. So if we look at our numbers, we've got 1, 2, 3 odd numbers. So 3 multiplied by 2 gives us 6, because if you take away 1 card, you're left with 2. So 3 multiplied by 2 for the number of combinations. Now we need to figure out the total number of combinations altogether. So for that, we've got 6 cards multiplied by 5, because if you use 1, you deduct 1, that gives you 30. So the probability is the number of combinations which give us odd, which is 6, divided by the total number of combinations, which is 30, simplifies down to 1 over 5, which is also the same as 0.2. And that is your answer. Question 23. So we have a figure that shows a solid sphere and a solid cone. We've got the radius, we've got the length, we've got the height. We've been told that the surface area of the sphere is n times the total surface area of the cone. So the surface area of the sphere is 4 pi r squared, if I'm not mistaken. Yes, 4 pi r squared. And the total surface area of a cone is pi r squared plus pi r squared plus pi r l. So from the information we can say that 4 pi n r squared is equal to pi r squared plus pi r l. And we need to show that the volume of the cone is this expression. So for volume of a cone, the formula is pi r squared h over 3. Now for h, that's the height. What we could do, this is r. If I form a triangle that looks like this, that's h, that's l. So L equals the square root of h squared plus r squared. Our expression for volume is in terms of r. So let's see, what we can do is try and find h. If I say L squared is equal to h squared plus r squared, h is equal to the square root of L squared minus r squared. Using this formula here, we can find out what L is in terms of r, and then substitute it all in, and hopefully it will work. So, to find out what L is, we can simplify the right-hand side. So, pi r is equal to r plus L. And then there's a pi on both sides. Oh, that's an n. Whoops. Cross out the pi, cross out an r. So then we have 4nr equals r plus L. So then L equals 4nr minus r. So then h is equal to 4nr minus r squared, take away r squared, is equal to 16n squared r squared minus 8n r squared plus r squared minus r squared, they cancel. And then if we factorize out r squared, 16n squared minus 8n, all square root. If I bring the r squared outside, it becomes r square root 16n squared minus 8n, which is h. So now if we go back to the volume of the cone, the equation is pi r squared over 3 multiplied by h. I've kind of shifted the h to a side because we've got a big expression to deal with. So if I substitute in h, that is pi r squared over 3 r square root 16n squared minus 8n. Simplifying that, it's pi r cubed over 3 square root 16n squared minus 8n, which is the expression we had at the start. So bingo, we've got it. Okay, question 24. So we've got the bearings. We've got a diagram with point A, point B, and we've been given the north lines for both of them. We've been told that the bearing of A from B is 137 degrees. So that is just this angle here. Using our knowledge of straight lines, if I draw a line, dotted line, continue that there, and then because A and B are parallel, this angle here is automatically 137. So by angles in a straight line, this angle here is simply 180, take away 137, which is 43 degrees. So then to find the bearing of B from A, we need this big angle here, which is simply 360, take away 43, which will give me 307 degrees, 17 degrees as my bearing.